Hello, this is Mr. Stansbury. We're going to go over the 3 C notes on Venn diagrams. At the end of this, you should be able to draw and decipher Venn diagrams using set notation and also the other way around. So, let's get straight into Venn diagrams and set notation. Alright, so let's start with subsets. Okay, so with subsets, let's just take a look at just a couple of different sets. We'll look at real general first, and then we'll take a look at some examples using this. So with subsets, let's say we have B is a subset of A. Okay, what that means is that B is contained within A, as every element of B is also in A. So in English, what that means is, if we're using a Venn diagram, it would look like this. Hopefully yours will look a little better, but you get the idea here. So here's a Venn diagram. This here is set A. Everything in set B is going to be contained within set A. Okay, so B is a subset of A, so every element in B is going to be in A. Okay, now let's take a look at intersection. Okay, so intersection. So let's look at A intersect B, right? That's going to be basically just where everything in set A, what everything in set A has in common with everything in set B. So let's call this set A, this is set B. The intersection is going to be this blue section here in the middle. So everything that's in both of those sets will be the intersection. Alright? Okay. So that's the intersection point. So A intersect B is right there. Alright, let's take a look at union. Okay, so let's do A union B. I know what you're thinking. What beautiful rectangles I draw. Yes, I agree. They're fantastic. Okay, A union B is going to be, let's call this A and this B, and again union means it can be in either A or B. So A union B is going to be all this stuff in here, right? In all of A and in all of B. Trying really hard to make this look pretty-ish, but I think you get the idea. So that is A union B, right? And again, just to maybe help visualize this a little bit better, there's set A, there's set B. So again, A union B is all of those. Alright, last one to look at is disjoint or mutually exclusive sets. So disjoint, which again, disjoint is also called mutually exclusive. Alright, so with that, you have, say, here is set A, and if it's disjoint, it doesn't have anything in common, so set B is going to look like that, and there is nothing that is in common with either of those. right? So A intersect B on this point. On this here would be, there is no intersection, so there's no overlap on these here. No overlap. No elements in A are in B, and also no elements in B are in set A. All right? So those are the four big things we want to look at. So let's take a look at some examples with that. Okay, so example 5 from page 74 is, given that the universal set is 1, 2, 3, 4, 5, 6, 7, 8, illustrate on a Venn diagram the sets, and then A is going to be, set A is 1, 3, 6, and 8, set B is 2, 3, 4, 5, and 8, and then for example B we've got set A is 1, 3, 6, 7, and 8, and then set B is 3, 6, and 8. So basically they're just asking us to draw a Venn diagram that includes set A and B, and what that would look like, and include those numbers within those sets. So really the first thing we got to figure out is if there's any common elements in set A and B. So right off the bat you can see we've got 3 is in common and 8 is in common. So there is going to be some overlap. So let's draw set A here, set B there, and again there's going to be overlap of the ones that are in common here. So that's usually the easiest way to draw this, is to find the ones that both sets have in common, right? So the intersection basically of the two sets is going to go right in here. That's the easiest thing to start with. So 3 is going to go in here, and then so is 8, right? So there's 3 and there's 8 from both of those. Okay, so set A then has 1 and 6 left over, so there's 1 and 6. Set B has 2, 4, and 5 left over, 2, 4, and 5 left over. And again, the universal set excuse me, has to include all the numbers 1 through 8. So let's see if we have everything. 1, 2, 3, 4, 5, 6. We're missing 7, but we have 8. So to include that in our Venn diagram, we just got to put 7 somewhere on the outside there. Okay, and that's how you would illustrate this on a Venn diagram. All right. For problem B, again, feel free to try these first and then take a look, pause the video, take a look after you figured out and see if it matches what I have, if you think you're getting this figured out. Okay? So let's take a look. Are there any ones that are in common? Yep, look, they've both got 3s, they both got 6s, and they both have 8s. Now if you look, B, 3, 6, and 8 are all in this set A. So really B is a subset of A. So what we want to do on that one really is draw all of B is going to be included in set A, right? So here's going to be set B. So inside of set B is 3, 6, and 8. Right? So all of B is taken care of. So all of B is inside of A. A also has 1 and 7. Right? And that takes care of everything from set A and B. Now we just have to figure out if there's any left over in the universal set that we have to put outside of A and B. So let's take a look. 1, we're missing 2. 3, we're missing 4. And 5. We have 6, 7, and 8. So that would be our answer for B. Alright? Alright, let's take a look at example 6 from page 74. Alright, so example 6 says that here's our universal set, 1 through 9, the integers, and then illustrate on a Venn diagram the sets. And then A gives us that set A is 2, 4, and 8, and then set B is 1, 3, 5, and 9. And then for part B, we have set A is 2, 4, 6, and 8, and then set B is 1, 3, 5, 7, and 9. So we're going to draw these on Venn diagrams as well. Okay, so 2, 4, and 8, 1, 3, 5, and 9. Notice that neither of these have the union, the intersection of these sets is the empty set, so there's nothing that these have in common. So that means we can draw A and B like that. And let's see, really we could do like little SpongeBob SquarePants here, couldn't we? I guess his hair would need to be a little bit more SpongeBob-y. Oh wait, I'm getting off track here. Okay, back to the problem. So we've got in set A, we've got 2, 4, and 8. In set B, we've got 1, 3, 5, and 9. Okay, and then also we need to, if you look at our universal set, we're missing, let's see, we've got 1, 2, 3, 4, 5. We don't have 6 or 7, so we've got to put 6 and 7 out here somewhere. And this is within our universal set. Not the union, but universal set. Alright, so if you take A union B, just as a sidelight, you don't need this, A union B is not the universal set. Okay. Over here on B, we've got, let's see, set A and set B again don't have anything in common. So I'm going to draw those as two separate sets there. And we've got A has got 2, 4, 6, and 8. Set B has got 1, 3, 5, 7, and 9. Right? And if you look at this, it's got all of the numbers in here, and there's no numbers left over in the universal set that aren't in both, like we had in example A. So in this case, A union B does equal the universal set. And again, this down here is just kind of extra info that you don't necessarily need to have down. All right. So really, that's all there is for this section here. If you have any questions, feel free to ask. Thanks.